All right, so we finished 6-1, or we finished 6-2, sorry. So now we're doing 6-3. So you've probably heard this word before, the zeros. Do you remember we talked about a zero of a function? Okay. Did we talk about zeros of a function? Yeah, it's the same as the root. Do you remember that? So a zero of a function is basically the same. You could say the root. All right. I don't know what's going on over there, but you don't have anything on your desk. You're not writing. You're not even looking up here. You could leave. In fact, I should ask you to leave right now, shouldn't I? I do in my CP class. I get rid of kids for not doing what they're supposed to be doing. If you just want to treat this as a joke, then you can just go. I don't need you in here. Let's try this again. So if I talk about that's my z. It's a weird looking z, I know, but it's a zero of a function. We could say the root, kind of interchangeable. In this lesson, in this chapter, we're going to use the word zeros probably more than the root of the function. It basically means this. It means it's the value for x for which f of x equals 0. So when I take my function, all right, it could be some long function, x squared plus 2x minus 3 or whatever. If I set it equal to 0 and then I solve for x, those are my zeros of the function. Does that make sense? So I'm just making this up. So don't write this part down. So if I had something like this, I have no idea what the answer is for this, but if I took this and I set it equal to 0 and then I solve for x, right? X equals this and x equals that. These two things are my what? Those are my zeros of the function, okay? It's kind of like saying it's just the answer. It's the answer for x. But you got to specifically set it equal to 0. Once you set it equal to 0 and you solve for x, we consider that to be the zeros of the function, or you could say the what? The roots, all right? But again, we are mostly saying zeros in here, all right? Just so that you know what we're talking about. So when I say, okay, find the zeros of this function, you're like, oh, I don't know what a zero is. I know what 0 is, but I don't know what it means to find the zeros. Well, what it means is you set that function, that f of x function, do you see that? Instead of writing f of x equals this, you would take that function, set it equal to 0, do the work, right? And then come up with values for x. Those are the zeros of the function. So we need to know what we're talking about before you get into there. There's something really important about the zeros of the function. I think we've talked about this. So I'll tell you what, we'll do this and this. All right, and so if I had a graph, let's say a parabola, right? Because these are quadratics that we're dealing with in here. So if I had a nice parabola like this, where on this parabola are the zeros of that particular function? The x, not just the x-axis, the x what? Intercepts, that's right. So that would be an x-intercept, and that would be an x-intercept. That would be a solution for x. So if I had whatever that function is, okay, if I said find the zeros of it, you could always look at the graph to see where they cross the x-axis, all right? Problem is, sometimes you have a parabola and it doesn't cross the x-axis. So what in the world are the zeros for this? Well, the thing is, they're not going to have any real zeros. Like, was there fake zeros? No. What does that mean? There's no solution for the x. Yeah, you could have imaginary numbers in there. Okay, you could have complex numbers. All right. So if it does not cross the x-axis, that means you're going to have some imaginary numbers in there because you don't have real values for x. If it does cross, sure enough, you got one here and you got one here. Everybody good with that? So that's what happens when you have that. Now they do an example. Let me grab a graph just to help me copy that. All right, and they actually, I think they draw a graph for you. I'll try to draw it the way they do. And what you have to do is answer a couple questions. And let's draw the graph first, though. So that graph goes through 2 and 4. I'll do this in red. So that graph goes right here. Oh, it's going to be kind of small. That's all right. We'll do it like this. And then it hits right here. All right, now we're not really sure how far up it goes, but we'll talk about that later. I'm not going to worry about it today. All right, but it probably goes up somewhere here when you think. There's my 2. This is where it crosses, and it also crosses here. So that means it opens down. Would you agree? And it probably looks something like that. I guess I could be a little bit more specific over here because watch. If on this side right here, how did I get to this point? I went over 2, right? And I went down, what? 3. So what am I going to do here? I'm going to go over 2, and I'm going to go what? Down 3. Why? Because it's symmetrical, all right? So let's get rid of that. I can be a little bit more accurate with it now. You see that? They didn't tell me that point. They told me this point. They told me these 2. And if I wanted to kind of sketch the graph, I don't know how far up it goes, all right, but that's okay. Again, it kind of goes like this, and then it's not pretty. You get the idea. You try it on this tablet. It's all slippery and stuff. It's not like on paper. But anyway, that's kind of what it looks like. All right. So what do we know about this? What is that point right there? That's my what? It crosses the y-axis. So that's my y-intercept. What is the y-intercept? So if they gave you a graph or they gave you an equation, they're going to do this in a little bit. If they give you an equation or a function and you can put it into Desmos, and we're going to talk about that today. We're going to use that today. If you put it into Desmos, you should be able to find the y-intercept. Okay, you click on it, and it should show you, put a little point right there, you hover over it, and it'll show you what that y-intercept is. So what is that y-intercept? It's a point. Where is it? It's right here, so it's what? 0, -3. Good. All right, so that would be your y-intercept. What would this be? This would be your x-intercepts, right? Or your zeros, but we'll call it the x-intercepts. The x-intercept actually has 2 ordered pairs, doesn't it? What's that first one right here? It's 2, 0. And what's the second one? It's 4, 0. Okay? So those are pretty important points. So whatever your x-intercepts are, it could ask you, I'll do a capital 0, Z for 0. They could ask you to find the zeros. If it says find the zeros, then what would it be? Okay, you would just say, you wouldn't actually put the ordered pair. You just say the zeros are what? 2 and 4. Or you could put 2, I don't know. Yeah, I guess you could put 2, 4. Just don't put parentheses around it because that would mean it's an ordered pair. That's not really what we're talking about. Okay, so you could say 2 and 4, or you could say x equals 2, couldn't you? Or you could say what? X equals 4. There's a bunch of different ways you could write the zeros. But if it says find the zeros, that's what you're finding. You're finding the solution for x if that function is equal to 0. Got it? All right, and you can also find it from a graph to find out where it crosses the x-axis. And again, sometimes you don't have any zeros. Sometimes you might have 1, 0, right? So you might have a parabola that just hits right there and goes up like that. So that point right there, you might only have 1, 0. Okay? Well, the no solution would be no real solution. So like if you had a graph that went like this, there's nowhere where it crosses the x-axis. So this would be no real solution, but there is a complex solution. Okay?
What about the sideways parabolas?
Those are hyperbolas. We're not going to deal with those till another chapter. Okay? All right, so let's continue with that. That was example 1, by the way. All right? This one, we're going to find the zeros and the y-intercept, but we're going to do it algebraically. All right? So that's what it says. So this is example 2. And it says find the y-intercept. Oops. The y-intercept and the zeros of the function. I'm not going to write function. but we're going to do it algebraically. Okay, so we're not going to do it graphically, we're going to do it algebraically. So we're going to do two of them. This is the first one, part A. They use R of X. They're just trying to show you don't always have to use F of X all the time. All right, it doesn't have to be an F. So they put R just to mix it up a little bit, make it a little more interesting, I guess. If that does make it more interesting, I don't know. Plus 2x plus 2. All right, let's do the y-intercept first. This is something I taught you in geometry. Do you remember doing x and y-intercepts in geometry when we did straight lines and all that kind of stuff? How do you find the y-intercept? To find the y-intercept, you're very good. You set the x equal to 0. Isn't that basically what we did here? Here's the y-intercept. So wherever x was 0, you just go down to where the y is, and that's the y-intercept. Make sense? All right, so let's do that. That's the easy part of this one. So it's just 1/2 times 0 is 0, plus 2 times 0 is 0, plus 2 is what? 2. So what's your y-intercept? We usually write it as an ordered pair. So the y-intercept is 0, 2. All right? And we could, and we probably will, put this into Desmos, take a look at it after we figure out the x, the zeros, and the y-intercept, okay? Just to see if it looks like we're doing it right, okay? It's just kind of cool to see us doing it algebraically. Then you put it into a program, you see the graph, and you're like, oh yeah, everything matches up just the way we thought it would, all right? I think that's kind of interesting. All right, let's find the zeros of the function now. So find the zeros of the function. I'm not going to write that, just find the zeros. So what are we going to do? Well, we're going to set this thing equal to 0. Remember that? That's how you find the zeros. So we're going to take that function, that r of x function, and we're going to set it equal to 0. And now we just solve for x. Just solve for x, okay? But yeah, it's not that hard. It's actually pretty easy. I don't like that 1/2. What do you think you can do with that 1/2 right now? Yeah, multiply everything by 2. All right, that'll get rid of the 1/2. It makes it a little bit easier to solve for x. So if you wanted to, you could keep it the way it is, put it into the quadratic formula, and then solve for x. But do you really want to stick a 1/2 in there? No, I wouldn't. So let's just try to make it a little easier on ourselves. So multiply everything by 2, multiply that by 2, multiply that by 2 as well. And technically, you are multiplying the right side by 2, but it's times 0. It's going to end up to be a 0. So that cancels. I've got x squared plus what? 4x plus 4 equals 0. All right. Can we factor this? Yeah. You could, at this point, put it into the quadratic formula. You could complete the square if you wanted to. Okay, there's a bunch of ways to do it, but the easiest way, I would always try to do it the easiest way, wouldn't you? On the same way. And if you look at it, it does factor. Put an x here and an x here. How do you know like what it is? Like, how do you know how it factors? Because this is a perfect square. Do you understand why it's a perfect square? If I take the square root of this, I get x. If I take the square root of this, I get 2x. And if I double 2x, what do I get? 4x. That's a perfect square. Do you see it? So both of these are going to be exactly the same. So that's what? Plus 2, plus 2. Would you agree? All right. And now what do? We set them both equal to 0. You're going to get the same answer. So let's just set one of them equal to 0. And what's x equal to? X is equal to -2. We actually get 2 x's, and we get -2 for both of them. Do we have to circle both of them? No, just pick one of them, and that's your zeros. So it actually does, I tell you what, let's graph it and take a look at it. Let me change this to, well, hopefully it'll pop up. Let me see it. Let's go to Desmos. And let me make sure that it pops up. I think it will. Come on. Come on, interwebs. Help me out here. All right, there we go. Let me just double check, make sure. Yes, it is on there. Okay, so let's put it in here. What was it again? I put y, you could put f of x on here if you wanted to, but I'm going to put y equals, what was it? 1/2. So let's go 1/2 x squared to get the x. It's a little easier to do it this way. X squared, and then plus 2x plus 2 plus 2x plus 2. So check it out. Do you see why? Look, how many x's do we have on this? We talked about this a few minutes earlier. We only have one x. You see, really we got two, don't we? But since they're the same, you just take the one. There's this thing called multiplicity. We're not going to really talk about it, but later on we may talk about the multiplicity. It's got a multiplicity of 2. But anyway, that's what it looks like. It would be right on. If you get one answer, it'll just be hit the x-axis at one point. Correct. Is that what you're asking? The axis of symmetry would be x equals -2 on this. Oh, yeah. It would be right in the middle. Yep, exactly. I know what you're saying now. It's right in the middle of that parabola. Exactly right. Okay. And what did we find earlier before we found the zeros? We found the y-intercept. What did we say the y-intercept was? 0, 2. Does it work here? Yeah, right there. See, if I hover over it, 0, 2, and hover over that one, that's -2, 0. It works out well. See how it's symmetrical? So watch, if I went over 2, I go up 2. If I go over 2 this way, right, from -2 to -4, okay, I go up 2, and boom, let's see. There it is right there. See, that's -4, 2. So that's another point on there. You didn't really find it algebraically, but you should know without actually having to plug in points in that that's going to be one of your points too. So you know how wide to make that thing if you were to graph it. This one says don't graph it, just find out what those values were. Make sense? Yeah. See how nice it is to do the thing algebraically, then you put it into the computer and you see the graph matches up exactly what we were talking about. Yeah, I think so. All right, let's get out of Desmos and let's do another one. Oops. I'll turn that one back on. There we go. All right, let's do another one. You ready? Let's see. What time are we out of here? 14? Wednesday's always so short. All right, let's do another one. Guess I probably could skip this one, but because it's kind of the same. But let's do it again. It's always good. Instead of r of x, they use s of x, which is kind of weird, but that's all right. Hardly ever see that. Here we go. We got -2. And they actually put it into a nice... Yeah, they put it into a little bit of a different form, okay? The one with the h and the k, all right? That's what they do on this one. So it's a little bit different. Plus 8. All right, we're doing the same exact thing. We're finding the y-intercept, and then we're finding the zeros, all right? So let's find the y-intercept first. The y-intercept, so what do? We make x equal to 0. So 0, let's do this. And we'll do it right there, -2. 0 minus 1 is -1, but -1 squared is 1, right? Plus 8, -2 plus 8 is 6. What's the y-intercept? It's 0, 6. So if we graphed it, if you go up to the 6, that would be your y-intercept, okay? That's not your vertex, but at least it's a point that we can find very easily. If we were to graph it, we could find out exactly where the y-intercept was. So that's helpful to us. It's very helpful. And again, if you know what the y-intercept is, you could always go across that same amount and put another point on there. It's not necessarily an intercept, but it will be a point on our graph. All right, so now let's find the zeros. All right, I'll just write that in zeros. So what do we do for that? Well, we take this, and what do we do to it? Set it equal to 0. Yeah, so that should be a good hint to you, right? If you're going to find the zeros, what do you do with this? You set that function equal to 0. Yeah, let's do it like this. You can do it a couple ways, but I'm going to do it like this. Let's move the 8 to the other side. Again, we're trying to solve for x here, aren't we? So I'm going to keep that the way it is right now. Set that equal to -8. All right, now what can we do? Divide by -2. All right, so that cancels. I got x minus 1. That quantity squared equals 4. Take the square root of both sides. So if I take the square root of this, I got to put plus or minus. So what do I get here? Plus or minus what? 2? Yeah? And then get rid of that 1, add a 1, add a 1. So let's come over here. So x is equal to what? Positive 2 plus 1, which is 3. And then x equals 2 minus 1, which is 1. So those are my zeros. So x equals 1 and 3. I think they actually do that in the book. They just put a comma right there. You could say x equals 1, x equals 3, however you want it. It's not, wait a minute, I messed up. It's -2. Let's see. What did I do? Plus 1. Why did I put -1? Right, it's -2 plus 1, which is -1. There you go, my bad. Check my arithmetic. You got to keep track of me, all right? Sometimes I go too fast and I miss stuff. There you go. So x is -3 or -1 and 3. So again, let's graph the thing just to see if it looks the way it's supposed to look, and we'll see how that goes. So let's put Desmos back up. And let's graph that one. So I don't need that anymore. Let's see, what do we got? We'll put y equals -2 parentheses x minus 1 parentheses squared. Put the squared thingy. All right, and then plus 8, right? Oh, that's not right. I put 22. There we go. Is that right? Yeah, that's right. That looks better. All right, let's check it out. Let's zoom up a little bit. Let's look at the y-intercept first. It's 6 right there, just like we thought it was, correct? Now, if you wanted to, you could always find the, on this one, it's set up perfectly for you to find the vertex, isn't it? We didn't talk about that. They didn't ask you to find it, but we could find it very easily because it was in that form. It was in that form with the h and the k. And what would it be? It would be 1, 8. And sure enough, there it is. That's 1, 8. So that's nice to know, right? Again, these are nice to know because if you're graphing it by hand and you don't have a computer or a calculator that you're allowed to use, all right, or an app, then it's nice to be able to know how to do that. And what's our zeros? -1, 3, just like we said it was going to be. All right, so you should, just by that information that we found, okay, you should be able to have a pretty good representation of that graph. Do you agree? Yeah. Probably would have never even dreamed when you were taking my geometry class and all we were doing is just y equals mx plus b and just getting a straight line and worried about the y-intercept, and that's all we cared about in the slope. You probably would have never thought you're going to be graphing stuff like this. But really, it hasn't been that difficult, has it? I mean, it's a little more difficult, obviously, but it hasn't been crazy difficult to find those things right there. So that's the fun about math, because you're always learning new things, and that's kind of fun. All right, let's do another one. Well, the next one's kind of the same, and really, yeah, let's do another one because 14. Everything came out really nice on the graph, didn't it? Okay. Oh, you know what I'm getting at. I'm going to do part B on example 3 because we're running out of time. This is probably the last one I'm going to be able to do. But even with, we didn't do inequalities. Let's just do this one. I'm not going to worry about that. The more I sit and look at it, the less time I have. They use Q of x. They're really stretching out the function things. Minus 2x plus 3. Okay, on this one, they ask you something different, I think. They just ask you to find the zeros, that's it. Okay? So what are we going to do? We're going to take this, set it equal to 0. Well, this looks nice and pleasant, doesn't it? Looks like you should be able to factor this, but can you factor this? This doesn't factor, does it? All right, I'm thinking, well, -3 and 1, but that's not a negative, all right? That's got to be a +3. So you got to have either both positives or both negatives. If I have both negatives, that'd be a -4. So this doesn't factor, all right? So what's really the only way? Well, not the only way. What's the best way to find x? Quadratic formula. Let's do it real quick. X equals -b, which is +2, plus or minus square root b, not b squared. What's our b? -2 squared, which is going to be a 4 minus 4ac. There's your a, there's the c. And that's all over 2a, which is that. This is 2 plus or minus square root. This is 4 minus 12, which is -8. Okay, so 2 plus or minus 4 times 2, right? So it's 2 square root of 2 with an I over 2. Divide both of these things by 2. What do you get? 1 plus or minus square root of 2i. Now, what does that tell you about the graph? Let's do it real quick. If the bell rings, just hang on for just a minute, okay? That's right. It's not going to cross the x-axis, is it? So let's see what it really looks like. It'll look like a regular old parabola. It's just not going to hit the x-axis. That's all. So what is it again? Y equals x squared minus 2x plus 3. There you go. See, it looks harmless enough, doesn't it? All right, but it's got the I in there, the imaginary number, which means it's not going to cross the x-axis. So it does not have any real zeros, okay? No real zeros. It's kind of weird, but you could find some stuff, right? If I click on that graph, see it puts that point right there. There's your vertex. You could always find your vertex by hand without looking at the graph, right? You can do that HK thing, right? That negative, what is it? -b over 2a, and then -b squared over 4a plus c, right? You could always do that, and you can find that to be 1, 2. So there's a lot of stuff that you can do with that. All right, we did not get to the inequalities, but that doesn't mean you can't do most of this homework, okay? So, what do you mean? What did you think I was going to do? I don't think so. I'll stop crying. All right, so 6-3, page 250, and we're doing 17 to 33, just the odds. 17 to 33, and you're only doing the odds, okay? Omit the inequalities. So anything with a less than or a greater than, don't do those. So that might be part of these, all right? But do all of these except for the inequalities because we didn't hit that today. All right, that's due tomorrow.